So, as we already know, a sequence is a set of numbers defined by a rule. If you didn't know that, then I would suggest watching the video on arithmetic sequences. But what a geometric sequence is very similar to a arithmetic sequence, but instead of each number being the last number, but like added a constant, this for each number is the last number but multiplied by a constant. For example, this sequence 4, 12, 36, 108, each number is the last number multiplied by 3. 12 is 4 times 3, 36 is 12 times 3, 108 is 36 times 3. And since we know that each number in this sequence is the last number multiplied by 3, we can say that r equals 3. And if this sequence was infinite, if it went on forever like this, 108 and then just kept going on, we can write a general term formula for this sequence. Now the formula for a general term formula for geometric sequences is like this. Un equals u1 multiplied by r to the power of n minus 1. If you've watched our arithmetic sequences video, you already know what n means. N is the position of the number that you're looking for. For example, u1 equals 4 because you're looking at the number in the first position in the sequence. Now, let's plug in all the variables we have into this. So we leave un as is, set it equal to u1. u1 we already said is 4 because that's the first term in the sequence. So 4 times, what's r? We have here, it's 3 because each term is multiplied by 3 and the last term to get the number. 3n minus 1. And this is our general term formula. And we can test it for a lot of the terms, for any term in the sequence. Let's say we want to find the third term in the sequence. We do u3 equals 4 times 3 to the power of 3 minus 1, which is 2. And this is equal to 4 times 9, which is 36. And let's look at the third spot. 36 is right there, which means this formula works for this sequence. Now, something interesting about geometric sequences is that if r is negative, or the ratio is negative, then the sequence can go back from positive to negative numbers. What I mean by that is if you have a starting number of, let's say 7, and you have a ratio or r of negative 2, then you have to multiply 7 by negative 2, which is negative 14, and then 14 by negative 2, which is 28, and then 28 by negative 2, which is negative 56. And this keeps going on forever, and you can see that each time you go up a term, it goes from positive to negative. And this is not something that happens in arithmetic sequences, only in geometric sequences. Let's do some practice problems. This problem is very similar to one that I did in the arithmetic sequences video, and if you haven't watched that one, I suggest you go watch it. But if you think you can do this problem by yourself right now, then pause the video and try it. What this question is asking for is to find x, given that these terms are consecutive terms of a geometric sequence. This means that each term is the last term multiplied by some ratio. So, x plus 8 over x is the ratio, because if you multiply x by the ratio, you get x plus 8. Also, 9x over x plus 8 is also the ratio, because you multiply x plus 8 by the ratio, you get 9x. And since these are both equivalent to the ratio, we can set them equal to each other. And we can also do cross multiplication to simplify this. So x squared plus 16x plus 64 is equal to 9x squared. And if we simplify this, we get 8x squared minus 16x minus 64 is equal to 0. And then if we factor an 8 out of this, we get x squared minus 2x minus 8 equals 0. and then we factor it like this, and we have our answers. X equals 4 and x equals -2. It's pretty simple. Let's plug in x's to this original sequence to see if they work. So the first term would be 4, second term would be 4 plus 8, which is 12, and third term would be 9 times 4, which is 36. And this works. The ratio is 3 because 4 times 3 is 12 and 12 times 3 is 36. Now let's try -2. First term would be -2. Second term would be 6 because that's -2 plus 8. And the third term would be -2 times 9, which is -18. And this also works because 6 is -2 times 3 and -18 is 6 times -3. Let's do another practice problem. This one's also pretty easy. If you think you can do it by yourself, then pause the video and try it. But the way to solve this problem is to look at the common ratio between these three terms. The problem is asking you to find the ninth term of this sequence, but you only know the first three terms. So we can see that the ratio of the terms is 2 because 3 times 2 is 6 and 6 times 2 is 12. So let's use the general term formula, which is un equal to u1, which is 3, multiplied by r, which is 2, n minus 1. This is the general term formula for this sequence. And if we want to find the ninth term, we just plug in 9 for for n. So we just do u9 equal to 3 times 2, 9 minus 1, which is 8. And this is equal to 3 times 10 to the power 8, which is 256. And 256 times 3, which is 600, plus 168, which is 768. This is our answer. This is the ninth term of this sequence. Now let's do one last practice problem. This one's also pretty simple. If you think you can do it, then pause the video and try it for yourself. But this problem is asking for the first term, u1, if the fourth term is 24 and the seventh term is 192. Now, we can figure out the ratio using these two terms. Let's do 192 divided by 24 first. This is equal to 8. But since these two terms are 3 terms apart, this means that 24 times the ratio again times the ratio again is equal to 192. So this means the ratio cubed is equal to 8. And we take the cube root of 8, which is 2. So the ratio is equal to 2. Now let's just count backwards from the fourth term. If the fourth term is 24, then we can find the third term by dividing 24 by 2. So u3 is equal to 24 divided by 2, which is 12. u2 is 12 divided by 2, which is 6, which means u1 is 6 divided by 2, which is 3. Now what we did here is we used these two terms and the values of the terms to find the common ratio between each term, and then we counted backwards from u4, the fourth term, to find the first term. So, all the problems that I went through and everything that I explained should teach you the basics I need to know about geometric sequences. There's also another type of sequence called arithmetic sequences, and we made a video on that. And if you haven't watched it, then I highly suggest go watching it, because it teaches you the basics of sequences that you need to understand geometric sequences fully. Now, if you learned something from this video, or you enjoyed it, consider liking or subscribing, as it helps us a lot.